Hello, I'm Richard with EV4U Custom Conversions, and this episode we're going to talk about calculating range. Yet again, we've talked about it in several previous videos, but we continue to have some questions. So today we're going to explain the formula in a little more depth, so hopefully that everybody will understand how we derived this formula. So, range formula explained in this week's episode. Stay with me. So what is the range formula? Well, the basic formula is pretty simple. It's your usable capacity divided by the watt hours per mile. Give you your range. So what we're going to discuss today is what's usable capacity, how do you calculate watt hours per mile, and how do we get to that range answer? Well, let's start at the top. What is usable capacity? Well, to get to usable capacity, we first have to know what the total capacity is. And to figure the total capacity of your battery pack, it's equal to the voltage times the amp hour rating. And so basically it's going to be the number of cells that are in series times the nominal cell voltage times the amp hour rating of the individual cells. So if you have 44 100 ampere hour cells, 44 cells, nominal voltage would be, so 44 times 3.34, basically 146 volts, 147, but I'm going to do 146 volts, times 100 amp hours equals 14,600 watt hours, or 14.6 kilowatt hours. This actually comes out to, I think 146.9, so it'll be 147 volts. This depends on what you want to use for that nominal voltage. We find that it's really, because we do a lot of these 44 cell packs, I know that the nominal voltage is basically 146 and change. So that's why I'm using that number, okay? So this then is our total capacity. Well, using lithium iron phosphate cells or any kind of cell for that matter, typically you don't have 100% of the capacity is usable capacity. And with our lithium iron phosphate cells, 80% is usable. So if 80% is usable, that's going to be 80% of this. All right? Which is going to give us 11 something here, I believe. So 14,600 times 0.8, 11,680. Sorry about that. So that's the usable watt hours. So that's the usable capacity. That part we now have figured out. So now, the next part in our formula was, remember, usable capacity over watt hours per mile. Now, how are we going to figure out watt hours per mile? Basically, what we're doing here is we're determining the energy available over the energy required. That's going to equal our range. Spelling this out a few different ways for you so that it clicks. So, energy available, that's our usable capacity of our battery pack. Energy required, that's going to be so much energy per distance. So it's easier to say, you know, watt hours per mile, because we figured our capacity in watt hours, so why not figure our requirement in watt hours also? And the common distance to use, like you do for gas mileage, it's the mile. So we're going to figure out watt hours per mile. So how do we do that? Well, let me tell you how we did that. So the energy required, this is the energy required to move the car a given distance. And so what affects this? Well, weight. Weight of the vehicle affects it. Rolling resistance. I mean, that's the tires, the running gear, you know, drivetrain. That's all resistance in the system. And tires being a big one. But road surface can be a big one. The amount of energy we use when it's raining real hard is much greater than it is on a dry surface. All these things are measurable because we have a energy gauge on the vehicle. We have an amp hour meter on board the vehicle, so we can see how many amp hours we're using at any time, how many amps we're drawing. So amp hours are keeping track of what we're consuming out of our pack, and the amps being used is instantaneous, like the instant fuel mileage kind of thing. We know how many amps we're drawing out of our pack at any given moment. And so we can tell when the terrain changes, like I said, rain, you know, water standing on the road, negotiating a turn, all sorts of things will create rolling resistance. So underinflated tires, big one. So the other thing that will affect the energy used per distance is the coefficient of drag. So these things are all factors in that energy required part of the formula. Now, these two are kind of hard to measure. But the weight is an easy one for us to measure. So we're going to do it based on weight. What is the relationship of weight to the energy required? So we're going to weigh the vehicle. And so what else can we do then? Well, here's the formula we use. We're going to test by driving a vehicle that we know the capacity of the pack, and thus we know the usable capacity. We can weigh the car and we know the weight of the vehicle. So then what we're going to do is we're going to drive the vehicle, test, and record. So we're driving and we're recording. So watt hours used, distance. We're recording those things, okay? Then we're going to calculate and then we're going to observe. From all these things, what do we observe? So let me give you some examples. Say we have a 2,300-pound vehicle. And we drive 50 miles. And we record that we use 11,500 watt hours. Same car, 2,300 pounds. This time we drive 20 miles. And we use 4,600 watt hours. So what we're going to do is we're going to do the math. And the math tells us that we're using and I'm going to run out of board again. I need to move the camera further back. And I'm using 230 watt hours per mile. So you see how I did that? Just simple taking the watt hours used divided by the miles traveled gives us the watt hours per mile. So we do that with different vehicles in different distances, in town, on the freeway. Here's another example. Say we have a 2,600 pound car. And we'll do two examples here again. And we drive 50 miles. And we drive 20 miles. And we observe the following. 13,500. what does this come out to? 260 watt hours per mile. What we had to do was we had to do enough of this and record the type of driving, the energy consumption and everything to find an average. And we would find that our average for this car at 2,600 pounds, we found that the average was 260 watt hours per mile. We found that on a 2,300 pound, it was 230 watt hours per mile. We found that on a 2,000 pound car, at X miles, would always come out to be an average of 200 watt hours per mile. So like I said, we had, first we did the test where we were doing our driving. We recorded the watt hours used, the distance, the type of driving, notes like that. And then we calculated the energy per mile. And then our observation was this relationship right here. The relationship between the watt hours per mile and the weight. And what do you see? Well, the pattern that we saw was that it was divisible by 10. So you want to know how many watt hours per mile that any vehicle was going to use? We divided by 10. There we have it. So the final formula then can be filled in. People ask, well, where did you come up with the 10? You know, for figuring the watt hours per mile. Right here. The watt hours per mile is the weight divided by 10. That's kind of the secret formula part of the formula, so to speak. That was the part that was derived by observation, measurement, calculation, and experience. And that's the part that people always have questions about, or most of the questions are about, is where does the 10 come from? Well, you saw. Came from observation. From driving, from converting and testing a lot of different vehicles. Mainly from 2,000 pounds to 4,000 pounds. This formula has proven to be very, very accurate. And we originally were figuring it based on amp hours, and so we had to calculate the using amp hours used into watt hours used. And so, like I said, by testing, recording, calculating, and observing, we came up with the formula. And so the formula is your usable capacity divided by your watt hours per mile gives you your range. And the watt hours per mile is the weight of the vehicle divided by 10. That's a good rule of thumb. The more cars we do and the more cars we test, the more we realize that that is the best. It's not 9.5, it's not 11. 10 is that real good average rule of thumb. And so that's how we came up with this formula. That's why we recommend this formula. But what we have found in driving in our test area, which is variable terrain, we go up and down hills, we do a 45-mile loop in our testing, 20-mile loops. So this rule of thumb works real well when you shake it all out. From city driving to freeway driving, basically when you average it all out, comes to that factor of 10. That's kind of a little more of an explanation of how we calculate range and how we derive the formula for calculating range. So I hope you enjoyed the video, hope you found some value in it, and if so, click the like button. I thank you for watching. Hopefully we'll have the components in for our Mercedes project, and we can continue with that. We're at 2.5 months and we're still waiting on the adapter coupler. And so looking forward to being able to share that next phase with you in that project. So until then, hope you enjoy the drive.